Now this will be the sixth class or tutorial under the same topic, logarithm, which will be the the final tutorial under this very topic, logarithm. Now we have logarithm involving special given logarithm values. Now this is to say some cases of logarithm, we are given some special logarithms. Now we are given something like log 2, log 3, log 7, and their logarithm values. And then also, while we are solving this kind of problem, we sometimes encounter something that has to do with log 5, which of course we were not given anything like log 5 here, and there's no way we can get log 5 from this 2, 3, 7. Of course, where we normally do something like times and just times. So since we deal with times, there's no way you can multiply any of these numbers randomly in order to get 5. So we now solve 5. Log 5 is equal to log 10 over 2. Of course, 10 over 2 is equal to 5. Okay? We now separate this by applying division law, which is log 10. We now give two of them their separate log. Log 10, because of division, we now say minus, then log 2. Now, of course, we know that automatically log 10 is equal to 1. Of course, this having when there's no base given, we assume that it is having base 10. So logarithm of 10 to base 10 is equal to 1, and then minus 2. So log 2 is equal to this very one we have here. In other words, we have been able to solve log 5. Okay, now let's now flow along. Logarithm of 16. This is the first question. We have logarithm of 16 is equal to log 2 raised to the power of 4 equals to 4 log 2. Okay, now we now have, how do we know that? This is, remember, our target is to make sure we work with just these numbers we have here. Of course, from 16, we know that 2 can help us with that. So 2 raised to the power of 4 has given us the 16 already. Now, we now say this 4 multiplies the log. That's following the power law of logarithm. 4 multiplying the log, we have log 2 left. Okay, now we now have 4 times, of course, log 2 is equal to 0.3010. Now, equals to 4 times this will give me 1.2040. That's it for the first question. Then the second question says logarithm of 147. Now, 147, how do we actually get the values that will be here? Now, I want you to follow me with LCM. It will be advisable for you to go with the LCM method, where we have 147. Now, from here, we look for the prime numbers that can divide this, which are also coming from here. Of course, into this, we have, what's that? 3 can go into this place. 3 here can give me 3 into 14 will give me, that should be 4, remainder 2. 3 into 27 will give me 9. So I have 49. Now, if you look at it, 49, 3 cannot go further. In other words, what I have is 7. 7 can go into this place to give me 7. And another thing will give me, another value will be 7, which is 1. Of course, there's 7 here. Now, we now go with, if you look at it, the reason why I didn't start with 2 is because this is an odd number. That's 1, 2, 7. There's no way that 2 can divide without a remainder. Okay? Now, that's why I started with 3. In other words, the values here, that will represent this is 2 times 7 times 7. No, sorry, 3 times 7 times 7, which is 3 times 7 times 7, which is equals, now that I have times, I will not start substituting until I have plus. These values are expected to be substituted only when we have plus. We are dealing with plus. Now we now have log. We now have to separate this in by giving them their respective logs. We now have log 3 because of times we now say plus. Log 7 because of times we now say plus again. Log 7. So we now substitute the values. Log 3 is equal to 0.471, which is this. Log 7 is this, which is with another one there. So adding everything here together, we have this. Now, the third question is logarithm of 28 minus logarithm of 15. Now, at this point, we still follow the LCM. From 28, we have 2. This is an odd number, so 2 can go. 2 here will give me 14. 2 here will give me 7. 7 here will give me 1. So what I have here is 2 times 2 times 4. That's the same thing with 2 raised to the power 2. That's 2 raised to the power 2 times 7. Okay, I can just go with 2 on separate basis, but I prefer taking this power. Now, we now have times 7. Now, minus 15 itself is 3 times 5. There's no way we can get it from here. So, of course, we know that 5 will be among. 5 will help us out. Now, following the 5, we now have logarithm of, separating this thing, to their respective logarithm. We have logarithm 2 raised to the power 2. Because of signs, we now take plus. Now logarithm 7. Okay, now minus. This one will now become logarithm 3 plus this minus. The reason why I put this in bracket is for this minus to affect everything here, both this one and this one. Of course, the times is giving me plus. Okay, so this minus should affect everything here. Now at this point, this power will now multiply the log. We now have 2 log 2 plus log 7 minus this. Now we have to focus on the 5 since we don't have value for 5. Well, remember what I said at this very point. So this we see say 10 over 2 is equal to 5. So we now borrow that 10 over 2. Now that's 10 over 2 here. Now at this point, everything here is still normal the way they are, since there's nothing to work on here except to substitute. We already have log 2, we already have log 7, which we have the values here. So we just focus on this. We now have log 10 minus, of course, division will give me, separating this one now, I have log 10. Because of minus, say minus log 2. Okay, that's division is minus. All right, at this point, I have everything on their own. We now have 2 times the log 2 is equal to 0.3010. Now, plus log 7 will give me, of course, there's 2 here. So that 2, these 2 here, I'll have to multiply this one. Now I have plus this is my log 7, minus, what I have here is log 3. Log 3 will give me 0.4771. Now, plus log 10, of course, is equal to 1, minus log 2 is equal to 0.3010. Now, close our bracket, we have 2 times this will give me 0.902120. Now, plus this, okay. Now, minus everything in the bracket will give me, that's this plus 1 minus this will give me 1.1761. Now, adding and subtracting here, we have 0.571. I can just add 0 to make it standard. That's 4 figures. But whether we leave it that way of 3 figures is still the same thing. Even if you add 1 million zeros here, it's still meaning the same thing. All right. So we now have 4. The next question is question number 4, which is logarithm of 0.9. Now, for 0.9, we have to convert this into fraction first, just like we did in indices. So having this, we have 9 over 10. Of course, 9 over 1. This significant number here is just 9. So we put that 9 over 1. Moving from decimal point, cover the number, we only move once. Since we move once, we have only 1 0. Now, that means giving us, since we now have division here, we have to separate this log. Separating the log, we have logarithm of 9. Because of division, we have minus. We now have logarithm 10. Now, already, logarithm of 9 is sent to it. Logarithm, we have to look for a way to extract a number from here. Of course, 9 is sent to it 3 raised to the power 2, of which I can still use 3 times 3. But I want to prefer using this power of 2. Now, I have 3 raised to the power 2 give me 9. Of course, I have 3 here, so I'm okay with it. So, minus logarithm of 10, of course, is equal to 1. Since there's no base, it's automatically having base 10. So, logarithm of 10 to the base 10 is equal to 1. Now, these 2, as a power, multiply this, we have 2 log 3. Now, log 3 is equal to 0.4771. 2 times this will give me this. Minus 1 will give me minus 0.04458. Okay, now the fifth question says logarithm of 75. Now, we have logarithm of 75 will give me, of course, 3 will go, the first number, this is an odd number. This 75 is an odd number. So, the first smaller number we should try is 3. Now, trying 3 into this will give me 25. Now, the next number that can go is 5, which is, although I don't have 5 here, but the next thing that should go here is just 5. So, the next one, that 5 here will give me 1. Sorry, will give me 5. Then 5 here again. Okay, 5 into 25 will give me 5. Now, 5 into 5 will give me 1. In other words, what I have here is 3 times 5 times 5, which is 3 times 5 squared. 3 times 5 squared. Now, I have now log 3 plus log. The reason, in this case, since I have 3 times 5 squared, I have to give them their respective log, because I can only substitute this in when I have plus. I cannot substitute when I have times or division. So we have to separate everything to plus or minus. All right, and we now have logarithm of 5 to base, logarithm of 5 raised to the power 2. Okay, for this one, the times now turn to plus. Each of them is now having their log. At this point, we now have this power now multiplies the log. We now have log 3 plus 2 log. Of course, 5 is not here. So we now still borrow this. So log 5 is entering with log 10 over 2, which is log 10 over 2. We now have log 3 plus 2 log 10 minus log 2. Okay, of course, this 2 is affecting both this 10 and this 2. That's why I left it outside, so that it will I left it outside the bracket so that it will affect both this and this. Now we now have logarithm of 10 is equals to 1, and logarithm of 2 is equal to 0.3010. Logarithm of 3 is equal to 0.4771. Then we have plus. Now at this point I have to solve what is inside the bracket. 1 minus this will give me 0.6990. Now 2 multiplied this 10 will give me 1.3980. Now I now have this plus this will give me 1.8751. Okay. Now that's the answer for this one. Now the next question is question number 6, which says logarithm of 1 raised to 1 whole number 4 over 21 raised to power 1 over 2. Now at this point we look for a way to convert this thing from mixed fraction to an improper fraction. So we now have we still have our power of 1 over 2. Now this power of 1 over 2 will have to come over to multiply, so that we'll only have this left. Now at this point we have to separate this one also. Of course this 1 over 2 will still continue to multiply. So we now have 25. This is separating this, removing this minus to minus, this division to minus. I have log 25 minus log 21. So we have 1 over 2 log 25 is sent with 5 raised to power 2 minus log 21 is equal to 3 times 7, which we have 3 and 7 in that number. Okay, so we now have 1 over 2 into bracket here is still supposed to multiply. Okay, into bracket 2 log 5 minus bracket. We have to separate this one as well. This minus should also be in brackets in order to affect both of them. So we have log 3. Instead of times, we have plus log 7. Close the bracket. At this point, we have 1 over 2 into bracket. 5 has to be dealt with in another way. Of course, the reason why we have these 2 is because these 2 have to multiply. Okay, 2 still comes down. This 5 alone is 10 over 2. Okay, now minus this minus will open this bracket. Minus times this will equal to this, and minus times this will be equal to minus this. So we have 1 over 2 into bracket 2 bracket. We still have to separate this one. So these 2 will affect this with a bracket. So we now have 10 over 2. That's we now have log 10. Instead of division, we have minus, then log 2. Now this one are still the way they are. Now we have 2 into bracket. Log 10, of course, is equal to 1. Minus log 2 is equal to 0.3010. Minus log 3 is equal to 0.4771. And log 7 is given to us as this minus here. Okay. Now it's equal. Log 7 is equal to 0.8451. Now we close our bracket. Then we now have 1 over 2 into bracket. Of course, 1 minus this will give me 0.6990. 2 will still multiply. Okay, minus this will give me minus 1.3222. Now we have 1 over 2 into bracket. 2 times this will give me 1.398, and then minus this. So this whole thing minus this will give me 0.0758. Now half of this will give me 0.0379. Okay, that is it for that question. Then the next one is question number 7, which is logarithm of 7 whole number 19 over 32, all to the power of 2 over 5. Now at this point we have to convert this mixed fraction to improper fraction. Now that is 32 times 7 will give me a particular value. Then will give me, I'm not with my calculator here. Then this times this will give me a particular value, plus this will give me 243 all over 32, all raised to the power 2 over 3. I have at this point, I would have said 2 over 3 coming to multiply this just like I did here. But looking at the numbers I have here, I can comfortably get a number that will be raised to power this denominator. That's 5. That will give me 243, which is 3. 3 raised to power 5 will give me 243. And 2 raised to power 5 will give me 332. That's 2 raised to power 5. Which I'll end up factoring out the 5, which I did here, and then end up cancelling this 5. So what our level will be 2. So that the figure will be easy for me. But I didn't do it here because there's no number, there's no way I can raise 5 to the power of 2 to give me this one. But it will not justify the denominator. I cannot raise any number to 2 to give me 21. That's why I didn't apply it in this question. So at this point we have logarithm of 5, we have 5 as the power here. Now factor out the 5 that come out to multiply the already existing power. So this 5 will cancel this 5, give me 2 only. So I have log 3 over 2 raised to power 2. Now this power of 2 is now what I will multiply with the log. So I now have 2 into bracket. Now this log 3, I have to separate this one as well. So we now have log 3. Instead of division, we now have minus. Now we have log 2 here. Now at this point, we now have 2 bracket. Log 3 is 0.4771. Log 2. Now we have minus log 2 is equal to minus 0.3010. Now this whole thing, this minus this will give me 0.1761. 2 times this will give me 0.3522. Now the next question is question number 8, which is log 0.42 all over 0.25. Now at this point we find out that this is a decimal. We have to convert this decimal to fraction. Okay, now converting it to fraction, we have the significant number after the decimal point is 42. It's 42. So we have our 42. Now all over 1. Since now we now move from decimal point, we have 1, 2. Since we move 2 times, we have 2 zeros. All over the same thing with the denominator. We have 25 as this 25 as the significant number. We have 25 here. All over 1. From decimal point, we have 1, 2. So moving 2 times, we have 2 zeros as well. Now at this point, we have multiple divisions here. In other words, we have to look for a way to reduce the division sign. Of course, this division can be changed to multiplication. We now have 42 over 100. Instead of division, we now have times. Once you change the division to times, the next number that follows, the denominator that follows, will be inversed. So we now have, instead of 25 over 100, we now have 100 over 25. Now, at this point, 100 will cancel 100. We now have 42 over 25. So we now have to apply the division law, which is logarithm of 42 minus logarithm of 25. Of course, given this one log and division will turn to minus, we now have log 25. We now have now 42 is something with we follow our LCM. We have 42. It is an even number, so 2 can go first. 2 going first will give me 21. Now 2 cannot go again. We have 3. 3 here will give me 7. Now 7 go to give me 1. So that, in other words, I have 2 times 3 times 7. 2 times 3 times 7 minus 25 itself will be 5 raised to power 2. And I have, having this now, I have to separate these ones. I have log 2. Instead of times, I have plus log 3. Instead of times, I have plus log 7. Now, minus log, this 5 multiply this, okay? We have 2. 2 log 5. Now, of course, you know, everything here is still the way they are. My focus is now to look for a way to solve this 5. Of course, 5 is not given. And of course, 5 is sent to 10 over 2. But I have to multiply this 5 over 2 by 2. Everything here by 2. The reason why I'm multiplying these 2, the reason why I put the brackets for this minus 2, to affect both the 10 and the 2. Okay? Which I'm ended up having log 10, giving them their respective log. Log 10, because of division, I have minus log 2 here. Close bracket. Now, log 2 is equal to 0.3010. Log 3 is equal to 0.4771. Log 7 is equal to 0.8451. Then minus 2 times log 10 itself is 1. Minus log 2 is equal to 0.3010. Close bracket. I have everything here added together will give me 1.6232. Now minus 2 times everything here will give minus 1 minus this will give me 0.6990. Now this will now have 1.6231. Sorry, this is supposed to be 2. Okay, so this multiplying this 2 minus 2 times this will give me this, and then this minus this will give me 0.2252. Okay, that's it for this tutorial.